Episode 4 of the History Channel's show Unidentified Inside America's UFO Investigation centers around 3 videos, commonly referred to as Nimitz, Go Fast, and Gimbal. All 3 videos were extensively analysed on Metabunk over a year ago. Nimitz is probably just a distant jet. Gimbal is also probably a distant jet, but this time with a rotating glare that's just an artifact of the gimbal-mounted camera system. But what I want to discuss here is the Go Fast video. This video appears to show an object flying very close to the water, which is how it's presented on Unidentified.
That thing is hauling
That's
ass.
exactly my point.
It's a little less than 2/3 the speed of sound.
This description is repeated on the To the Stars Academy page, where the video was first released. A white oval shape moving at high speed, flying very low over the water. But is it really low and fast? No, it's not. It's actually high and slow. And we can prove this with the information in the video. There's a bunch of numbers on screen. The altitude of the jet is pretty constant at 25,000 feet. The calibrated airspeed in the lower left is also fairly constant at around 255 knots, which gives a true airspeed of 370 knots when you correct for the 25,000 feet pressure altitude. The jet is flying straight at first, but after locking on, it banks about 13 degrees to the left. I extracted this information by feature tracking the ends of the horizon line, so the jet's turning a little bit to the left. The number at the top is the angle of the camera relative to the front of the jet. It goes from 35 degrees left to 58 degrees left. The number on the middle left is the camera's downward tilt. It goes from 22 degrees down to 35 degrees down. One of the more important numbers here is the range number, on the right-hand side, labelled RNG. This is the distance to the target in nautical miles. It does not show up until the target is acquired, but then it goes from 4.4 nautical miles to 3.3 nautical miles. So we can use all these numbers and how they change over time to do 2 things. Firstly, we can calculate how high the object is. That isn't too complicated. We know the angle the camera is looking down at, and we know the distance to the object. So the height of the object below the camera is really just simple trigonometry. It's the range multiplied by the sine of the downward angle. If you take the object at the start and the end of the tracking, we get 4.4 nautical miles times the sine of 26 degrees gives us 1.92 nautical miles below the plane. Then at the end, 3.4 nautical miles times the sine of 35 degrees gives us 1.95 nautical miles, about the same. Then it's an object that's around 13,000 feet above the water. And it's also being viewed from a jet at 25,000 feet, so basically it's halfway between the jet and the ocean surface. This is very important, because it means the perceived motion of the object against the ocean surface, even if it were moving very slowly, or even if it were not moving at all, would be the same as the speed of the jet itself. This parallax effect is hugely magnified by the high zoom, which is set to NAR, narrow, or around 1.5 degrees field of view. So, we've already seen the unidentified analysis is wrong. It's not close to the water at all. It's at 13,000 feet. But is it, as they say,
It's hauling
That's
ass.
exactly my point.
It's a little less than 2/3 the speed of sound.
hauling ass and 2/3 the speed of sound? No, it's not even close. It's going as slow as 20 to 40 knots, just wind speed at that altitude. We can determine this with some slightly more complex analysis. So we know that the jet and the object maintain constant altitudes. The object at 13,000 feet, the jet at 26,000 feet. So we can restrict the analysis of the speed of the object to an overhead view. Now, given the range and the angle relative to the front of the jet, we can plot an initial position for that object relative to the jet. Then we know the speed of the jet and the time of the locked portion of the video, so we can plot where it will be at the end of the video. Then using the final range and the angles, we can plot the end position of the object. We can then divide this distance travelled by the time and we get the speed of the object. This depends on how much the jet is turning to the left, but putting in a reasonable turn rate, and we get the object speeds in the range of 20 to 40 knots, maybe a bit more, but it's all consistent with wind speed of 13,000 feet. Not another jet, and certainly not 2/3 the speed of sound. We can also make a rough estimate of the size of the object based on the field of view, the range, and the fraction of the field of view covered by the object. This gives us a size of about 6 or 7 feet, about the size of, say, a weather balloon. In Unidentified, they notice that the craft appears cold on the infrared, and the narrator says,
"There is no known aircraft that can stay aloft for long without a source of lift and propulsion."
which is false, because there's an obvious type of aircraft, a helium balloon, which appears cold in infrared and can stay aloft for hours, even days. It can also look like it's moving really fast over the ground when it's actually just parallax. Here's another example where a balloon is clearly just a balloon, it's also barely moving, and it looks like it's moving really fast. Balloons themselves don't reflect radar, but weather balloons carry radar reflectors, which will be very easy for the range-finding radar to lock onto. And finally, in the Defense Department's Form 1910 that authorized public release of this video, the description specifically mentions balloons. Does this solve this one particular video? Not 100%, but it's a quite plausible answer that people are ignoring. Maybe they just didn't do the math, maybe they didn't like the answer, but you can't ignore it as a possibility.